So basically, trying to fill in the blank. We want to create this tool, create this design automation to help this kind of customization for everybody.
Welcome back to the Fourth Space podcast. For today's episode, we sit down with Dr. Tsz-Ho Kwok. Dr. Kwok is an assistant professor in the Gina Cody School of Engineering in Mechanical, Industrial, and Aerospace Engineering, and also a researcher at the Center for Advanced Manufacturing. In this episode, Prem Sooriyakumar, knowledge broker with the Office of Research, sits down with Dr. Kwok to find out more about his own research, his interest in origami, and the many different research directions he is currently exploring with his students. We would like to begin by acknowledging that Fourth Space and Concordia University are located on unceded indigenous lands. The Kayunkahaga Nation is recognized as custodians of the lands and waters on which we gather, and Tsz-Ho, Montreal, is historically known as a gathering place for many First Nations. We respect the continued connections with the past, the present, and the future in our ongoing relationships with Indigenous and other peoples within the Montreal community.
Hello, Dr. Kwok. Nice to see you again.
Hello. Nice to see you.
So I was just looking at the news, and congratulations on your award on Outstanding Young Manufacturing Engineer Award.
So that is an award from the Society of Manufacturing Engineer. They want to reward the people that have a strong contribution in this manufacturing community.
Can you maybe tell us the story how you got interested in manufacturing, or how you wound up this being your key discipline and you're advancing and transforming the manufacturing industry?
Put it this way is I actually quite motivated to do things, help human to live a better life. Someone once mentioned that people is not disabled. It's the technology itself is disabled. We have so many technology now, but we are not able to help people. We are not able to help them to live as the way that everybody can live. So I'm very interested in doing this kind of a human-related product, even starting from my PhD graduate degree. I already work on this kind of customization, personalization, design. And one of my research goals is to realize or implement the true mass customization.
So if I could kind of summarize, all your work is kind of leading to how do we get mass customization at a certain economic, affordable cost. And looking at all the research projects that you're doing, and you have it organized under several fields, then I'm curious as to, out of all the fields that you're working on, that the most you're attached to and I think is important to advancing this goal.
Actually, all of them are very important. It is a different set or different direction to achieve the goal, and missing any of them will not work. For example, from my side, I cannot do everything. So I pick two major things. One is design. We need computational design that are able to efficiently customize the products so that you don't need a designer to do everything. Secondly is we need new manufacturing method, process, and system. Then there is two scenarios that you can think of. One is like today, what we do online shopping. We buy things online, maybe in Amazon, we buy things online, you click a through button, and then boom, suddenly it comes up your front door. So that is one thing. Another thing is you go to in-store, so face in person, and then you get the product right away. In these two cases, the online one, you can still do the manufacturing in the factory. But if the in-store one, you cannot do this. You have to do the customization on site. So no matter what, you need the way to do the customization. But then, for example, cyber manufacturing or smart manufacturing, that is talking about in factory, how you do this. And then we have something like called the functional fabrication, and we also have design for additive manufacturing. That is very important for the quality, for the wheel fabrication. Even we have 3D printing can fabricate anything. We call it fabricate anything that you want. But nowadays, we are still having very limited use. But there is still a lot of things we need to do to improve the quality, to really make repeat prototyping or 3D printing to be the repeat manufacturing, not only for prototyping, but a quality, functional, guaranteed product can be fabricated.
I'm just curious. So 3D printing plays a key role, advancing 3D printing through computation, AI. And as part of, obviously, we need logistics. We need to be able to get that manufactured product to you. But in your specialty, you have these categories: design for additive manufacturing, functional design and fabrication, cyber manufacturing, product design and customization. And I'm kind of curious of some of these key projects that we can discuss that you're super excited about, or that's kind of fueling your curiosity and driving some of your interest.
So let me do it this way. So roughly, let's say design for additive manufacturing. What does it mean? It's talking about we want to fully utilize the capability that given by the new technology, the 3D printing technology, the advanced manufacturing technology. Not just 3D printing. Nowadays, 3D printing by itself is not sufficient. Our design methodology have to be upgraded. In the past 5 years, let's say, the manufacturing technology have been updated really exponentially. But if we are still using, let's say, SolidWorks, let's using some kind of like AutoCAD, which are talking about developed like 50 or 30 years ago software, which are very good for the traditional manufacturing, but they cannot do things for the new manufacturing method. That is why we need this design to fill in the blank, to support the development of manufacturing method so that we can have real rapid manufacturing and the product is good, not just something like looks like a toy. Functional design and fabrication is more concerned in terms of the functionality or the performance of the product or the manufacturing itself. As mentioned, one thing a key why they can get the furniture so cheap that you can get them, and then even so that you can still enjoy the assembly process at home. That is the beauty of it. They make you work, but you work happily. So that is the tricky thing. The similar concept is true because if you already assemble everything, then the shipping cost will be huge. Then you won't like it. I'm buying a $50 stuff and then turns out my shipping cost is $100. You are not going to buy it, right? But they design in a way that they separate into pieces, but then those pieces can be shifted easily. Then you do the assembly and boom, everything is there. That is the beauty of it. So one of the functional part is also like this. It's talking about, let's say, design for the assembly. If the product by itself is smart enough, we are not even talking about I want you to do the assembly. Because sometimes if you need to do the assembly, it's still difficult because maybe someone is good at it, then they are happy. But if someone's not really good at it, they will hate it, right? So we want to do something is we program the material. Maybe what we are shipping is just flat. And then finally, we give different condition. Then we can stimulate it, trigger it to become a final step. It will be self-configured, self-assembled. That will be fantastic. And more importantly, it's not just talking about it's assembled to one shape. It's you can control it to be self-assembly, to finally self-assembly to different shape. Then you can incorporate customization into it at home. Then cyber manufacturing, or in other ways related to the smart manufacturing, is talking about you need to do process monitoring. Your factory need to be capable, like you can capable to deal with different things. For example, just one example, mass production is fine. You can put the part is well divided. You can produce more or less. It's just after producing A, then you producing B. So you are well structured. Everything is the same. Creating the shoe, you know exactly how it looks like, how to grab it, how to move it to the other places. However, if you're doing mass customization, what will happen is every individual part is different. How are you going to handle it? Then we learn from human body. We learn from ourselves. Our muscle, our tissue are designed very intelligently. We have this capability to do different things. So we try to incorporate like human body. So soft robot is one thing to mimic human body. Control system, feedback is like mimicking our like sensing system. AI is mimicking our brain. So basically the same thing. We want to make a factory more like human, and that is how we call it smart manufacturing. So that is the part. Finally, like design and customization. So we need tools to help us to do customization. Even up to now, today, I even give you a 3D printer at home, what you can print. Even up to date, saying that, so many things are making, but we don't have it. Arm cast. If you broke your arm, nowadays you're still using the bulky ceramics mold to cover it and it sink and also is stretchy. We have the technology to 3D print an arm caster apply to help you for the rehabilitation, to help you for the blood recirculation. We have all this technology. But today, even that this is doable, you don't have the way to do it. You don't have an efficient, you don't have a easy way to do it. So that is basically this part is trying to fill in the blank. We want to create this tool, create this design automation to help this kind of customization for everybody.
I'm kind of tempted to ask you about the projects because some of them have some really hot, exciting, futuristic concepts to them, like your origami. But I was wondering, before we get into that, I'm curious, because it is a multi-prong, you're working on these different layers. How do you kind of conceptualize and decide, like, this is the project I'm going to develop? I'm just so curious, how are you looking at this and the kind of end goal or advancing within your field?
Well, I mean, what I know is this governing topic. Then underneath there is tons of topics to do. I don't actually need to think about what I need to do because you just look into the missing gap, missing knowledge. We will know what kind of things need to fill it up. How I decide what topics to do, I will tell you the truth is I don't really need to. What I do is for myself, I do have my own interests. For example, origami or there's some kind of computer-aided manufacturing. I will do it myself. I just simply at home, I have a 3D printer, then I can do that. Other than that, I have a team of graduate students, right? So basically, I will let them to choose. So I will ask them, okay, now you come to the graduate school. Why? What kind of things you want to do? Whenever they mention something they want to do, for example, they at the grand trial they already like very very into this kind of like robotics. Then I will tell them, okay, yeah, for sure, why not? Then we will look into something the robotics in factory, robotics at home, this kind of smart robotics. Then soft robotics is one of the topics that is how we created or we developed in this direction. Then sometimes some of them saying that, oh no, I'm interested in working on human product. Let's say I like sport, so I want to look into shoes. I want to look into this kind of particular applications. Then I say, why not? I mean, as long as this fall into the mass customization umbrella, everything we can work on. As long as we just treat it a little bit or forward the particular direction, everything is the contribution towards the goal. So then we do it. We try to work on it. We study about the shoe. What is the problem right now? And then we know that they try to design fancy shoe, but they're not really looking at the energy performance. Then we try to study it. We work on that. So as you can see, I honestly I don't have to, because this topic is very wide and very multidisciplinary. My belief was, as long as the student the researcher love what you're doing, you will find the connection.
Okay, now let's hear about the projects that you love. Curious to hear about the kind of origami approach.
I do love to use a paper to fold up certain, like even just a box or sometimes a rose. So the funny part of origami is that you start from a paper, but then it becomes a 3D shape. It's just simply a set of like folding, bending, deformation. It is actually fascinating. If you can think in this way, is that similarly, just like the IKEA, this application I mentioned before, if we do something similar, Refabricate is purely a 2D sheet, and then we go to the store or go to your home, and then you just need to do certain folding or certain this kind of deformation, you get your final product. Then that will change a big story, because the logistic or the shipping costs, all those things will be greatly reduced. So that is one thing. So I myself get into interest in origami, and then I think about how origami could be used, could be beneficial to the mass customization idea of the origami. We try to apply it and then to understand what is happening. But of course, not just the manufacturing process is changed to deal with this kind of thing. You also need to, if you want to do something really useful, you need to understand how the deformation will be done, how the deformation will looks like. So we have the simulation, we have the modeling, we have the control over there. So all set of this combined together become the origami research that we have been doing so far.
I think what's exciting about discussing manufacturing, and especially this mass customization, it affects all of us. It affects the public in general. It's not a specific aerospace technology that's going to advance a certain industry, but it's like has the ability to affect us all. And I think having someone with your disciplinary background, I can't help ask about the future, right? In the sense that we know that the work that's happening right now is maybe 10 years, 20 years, down the road. And I'm curious, from the work that you're doing, I would love to hear more of your reflection of how you see it evolving and becoming part of our society.
I would say gradually. It's not like boom, suddenly then we get mass customization. I can tell you the truth is I'm also working with multiple companies. I try to put different efforts to push our industry, puts the boundary to move a step, maybe just every time a little step over there. For example, you may find funny is that I am working with a company. We are working on the artificial nail. We have been working on this for at least half a year to develop tools. We try to make a particular tool, customization tool for this application. Suddenly, everything will be easy. It's already so many challenges we need to solve so that non-designer, and non-engineer will be able to do this kind of customization easily. I can tell you the results are very impressive. Previously, if they need to do a set of this kind of like 10 fingers, they probably need a couple of days because each of them at least take you a half an hour to just talk about from the scan, extracting the nail. And then after that, you take another few hours to do the design, to do the modeling. And then finally, you go to do the fabrication. You take a couple of days for one kind. But now we developing the software to help them to do this thing. Even a non-designer, we have tried to find the way how user love to do the interaction, because mass customization, we need to involve the customer. We need to involve the user into it. Then while we are involving, we can involve them to do maybe a few clicks or involving them to do something. Just like IKEA, involving you to do the assembly. You will love it. You will like it. Then this is the thing that we are trying to do. Try to see how the involvement will look like. And after we know how the involvement looks like, then we develop a set of tools. Maybe we need to also modularize this customization tool. Do your own customization, not just for yourself, for the edge, any other part. Customization is not just talking about fitting your body. Okay, customization is different things. It's customizing performance. Even just talk about jewelry. It's not talking about fitness. It's talking about the shape, how it looks. So those are still customization. So that is how I see. So step by step, we will find a way to unify the whole customization tool to develop and propose a framework that can work for all sorts of customization.
That's a great conclusion. Thank you so much, Dr. Kwok, for you're opening the door to this topic. At some point, maybe we can talk again to talk about some of the work you're doing in sustainable materials, working with hemp and fibers, etc. But thank you so much for opening the window to exploring the potential and all the disciplines that are intersecting around mass customization.
Thank you. Thank you so much.
Thank you for listening to the Fourth Space podcast. You can follow us on Facebook, Instagram, Twitter at CU Fourth Space, and wherever else you find your podcasts. The podcast is hosted by me, Douglas Moffat, and produced by Anna Voklovec. Editing by Chloe Lalonde and Makai Halgro. Social media and web support by Kari Balmstead. Our theme music is courtesy of Supercontinent. Thanks for listening.